now let's do the speakers.
Can you hear us?
Can.
Okay, but
Yep.
Okay, are we ready?
I think so.
Can we see you as video, or you cannot see? I cannot see you. Not
I will turn it on.
okay.
We'll see if it all goes downhill from here.
If we see the sound being chopped, then we can disable the video, but it would be nice to see you guys.
Or you can stare at me for the whole time. Up to you.
Oh, this is I don't see the audience. Okay. So I see my beloved fathers there. It's such a pleasure. So with their permission, we will start in the name of the Father and the Son, and the Holy Spirit, one God. I mean, absolve me, my fathers. So by God's grace, this a work that is mandated to be delved in, and of course it hits close to home because this is things we were actually creating in the 90s, and by God's grace, because of the opportunity that God has provided to work in this field, not at its very infancy, but when no internet, YouTube was available, everything is made by hand. You have to code everything from scratch. So that created familiarity that very hard to forget, because it's nights and days when you're actually coding yourself, whether whatever, mainly languages that were used then were the C and the object-oriented was just coming out in 1992. So it was and it hits home very closely to delve into this now when it's imposing itself on us, and it was natural because the human beings are obsessed by recreating themselves out of themselves. That's the main thrust of automation and robotics and what we call intelligent systems, but now it came into learning systems, and hence AI. That will be later on, but let's delve into this. For the basic knowledge, bear with me in these parts. What is AI? Because this is general presentation, so I assume the audience haven't been exposed to it, so at least we'll give a touch. If it doesn't click, it doesn't matter. We can just deal with the second two parts, which is some examples of using it in the ministry. And then what is more important for us as faith and dogma, the philosophical implication of the field on the faith. And I will vouch for something that hopefully will remove the fear. It will require more work, but we'll discuss it maybe if it's part two, because I'm have quite a bit of material. I'm not sure if we'll cover it all in one session, or we can have another appointment for another session. It's the quest of humans to delve into how the brain works, thinking machines. There's no way that man will stop to figure out how the mind works. And the mind of man, because we create things out of nothing, and the process of thinking and the process of memory and the process of learning makes, if we can recreate this, then we're achieving, we cannot leave this part untapped for a human, because we're always in a quest of knowledge. Man is always in continuous quest of discovering himself. The most enigmatic thing about humans is not the motor function, which is in robotics, is not just intelligent systems that can make decisions, but the learning, the thinking, the solving a puzzle. The human intelligence is the holy grail of man's quests. And then now because emergence of robotics commercially made it very pressing itself on us. Is there any question? I'm just hearing some sounds. Please stop me if there's any question. We can stop and answer. So I thought that AI should be divided into two parts, as a tool and as philosophy. As a tool, you're all familiar with it and use it day in and day out. We may harness it later to do other applications in the church, whether it's search or other things, or delving into the mathematics of it to if time permits, I can give examples of these. But as a tool, we're all using it. It's like the internet, very, very available, and it's very stunning of what amount of information it can gather together. For now, we have to be careful that this should be not used directly online or live, because of the information it might give out might need to be filtered, as we'll see soon. As a philosophy, that's very important for us to delve in the effect of having machines that can think, and how will that affect the human existence, or the philosophical implications of humanity. What is a human? Is it just a thought? Are we just cells? Are we able to create machines that are better than us? Hence, we're just like a small chain, a small link in a chain, and we created a better version or a better species of humanity. Outside world thinks this way and pushes for it, so we have to be able to address this as well. First, what is artificial intelligence? It is the intelligence manifested by machines, a new way of computing. Computing before was by paper and pen, then it became systematic when you have hardware machines that can go from one state to another. That's digital logic, and then computational logic. And then there is the flexibility on the hardware and that software, which is coding. And then comes what we call connectionism. That's the new way of connecting mathematical elements together and then letting them figure out what we're asking it to do, as we'll see shortly. We experience it today most in applications like ChatGPT, Microsoft Copilot, and you can list all of the applications better than me that are available there. Large language models. What is that? So this is the essence of what artificial intelligence is: a model, creating a model, creating it as things connected together. We'll see what the basic formulation of that things are, and then training it. So this is the key word here: a model that has been taught, and then when it's left alone, it can continue teaching itself. Or it can be taught manually again, over and over. So this is LLM, or large language models, is what is the backbone of these engines. But the key here word is model. So we're going to discuss this. The human mind and computing, that's the evolution of us dealing with computations done by the mind, or the brain being the hardware of that work of the mind. First, mathematics and analytical methods, and then computational language and logic, that's programming basically, and then connecting computing elements together, and then making this solve a problem for you. That is what's the current AI is. The birth of this came, that's why it's called, it's an infancy, which is what we were doing in the 90s was called, AI was in the form of expert systems. This is a bunch of rules, and it was promising a lot of success, but it's still used in oil well explorations and some systems in diagnostics. It's called expert systems. And then the other one is connectionism, and it's called neural networks pertaining to the neurons of the brain. And the neurons of the brain, they have input from a previous neuron. It goes, when they're activated, the signal threshold is high enough, it gets transferred to the end of that neuron through the axon. And that is what Rosenblatt in 1964 invented this term neural networks, or connectionism. That's what he coined connecting computing elements. If I can model this mathematically, I can connect it and see if I can do something with it. There has been winters in this, means that it lost traction, it lost funding. And then with some more work, it gains some traction, and then it loses it again till in 2010 or 2012. Some researcher in the University of Toronto did an amazing success with the ImageNet, and then it became an explosion since then. And it was called deep. I'll tell you why soon, deep learning. So what we learn now is connecting elements together. If we model this mathematically, can we connect some together and make it useful to compute things for us? So that's really a mathematical recreation of what is called a neuron in the brain. This is input. There's details here. This is called the DC offset. The input is multiplied by weights, which gives strength to each connection here. So it will be x1 times w1. If this is x1, then the connection of it and the addition of these signals, it's what happened in the neurons. To see if all of these inputs will go to the next stage. There is the addition of all of the inputs multiplied by the weights. There is nonlinearity here. That's no need to discuss why, but that's essential in mapping problems that are nonlinear spaces, and that's all real world problems are probably nonlinear. And then this is the output. That's just a very basic connection element, and that's why it's called a network. So
Sorry, Abun, I have a question.
yes,
So is AI then trying to imitate the way that the human mind works?
we'll get into this a little bit more when we see the training. Just
Okay, sorry, Abuna.
no. I said ask any question. So because if it's in your mind and you forget it, we'll not address it. But we'll see. This is just the basic component in what I'll show you later how it's used practically. So
Thanks, Abun.
I'm sure it's the transfer of a biological element into a mathematical element. So what is y is w naught times 1 plus x1 times w1 plus x2 times w2 plus xm times w, whatever, how long this is. It's not just 3, it could be million elements long. This sigma is, that's what I'm saying, plus. It goes through to nonlinearity and gets a single output of all of this multiplication. That is called a neuron. An electric neuron or a mathematical neuron, using the same terminology as how the brain fires in order to transfer information or think. What a basic decision making does is if I'm offered blue circles and red circles, a basic element that this Rosenblatt started testing with, can I develop mathematics that if I show it these dots and I tell them it's blue, and these are dots and I tell them it's red, and I want to separate the red from the blue, can the network find a separator, or what we called in mathematics a classifier, that can separate this from that? The classifier means I made a decision that us do very easily with our eyes looking at it. Oh, I can really point a line easily to separate the blue from the red. That is not easily in a computer. It can be done analytically, of course, but then people were interested if we can do this by showing it data, and we'll get to the part of training soon, and then let it figure out this line, where this line should be. And that's where the very beginning of using it to classify between two sets of data, and that was the birth of it. Here is an example of using it commercially, and maybe this example will show how it works. I hope I can do a good job at it. So if we want to recognize handwritten digits, and AT&T Bell Labs did the system for the postal services to recognize the zip code in order to automate the routing of envelopes. There's nobody that sits and looks at the zip code. So one of the very first practical application, was the development of handwritten digits recognition. So we'll use this to explain the concept. So create many shapes of the same letter, of the same digit, excuse me. Create many shapes of the same digit. How do we feed it into it? Feed it into it, digitize it, make it into the form of first label them. Because labeling meaning telling it what it's looking at. So if I feed this into it, I'll show you soonly. I have to tell it from outside this is a 5. And then if I feed this picture into it, I have to tell it it's a 0. That's called the training. I feed it information and I tell it what it is. Later on of this information, if it's trained well or the model is doing well, if I write this 5 in a different way, the network will able to tell me it's a 5. That is the process of training which will embark on. So you have to label them, means tell it what's the output. That's when you train a baby, like you let the baby handle something, tell it it's a dog, it's a cat. And so this training that we do with humans, you show it something and tell it what it is. If the baby sees a cat in a different color or in a different format or in a different size, the brain should be able to tell it this is a cat, although it's not the same cat that they saw before. That's the whole idea here, is to train it to data that it can generalize later on. If you show it the data in a different way, the model is generated well, is trained well, it can tell you what you're showing it. So this is basically the training or the idea of the basic idea of AI, but it can be generalized. There is so much more complication now, and applying it to text is going to be very hard to explain how this is applied it to digits or to images is easier to explain than if we apply it to how the text recognition happens or sentences happen or how does it finish your sentence. That's a completely different ball game. But the basic idea is concept of training. So here I'm explaining what training is. So this is a digit written by hand. So we want to feed it into this network. So to feed it, you make the digit into a picture. And then you tell it, this is the output, tell it it's a 3. And then it has to figure in the middle here how when it sees this letter in a different way, this digit in a different way, it will recognize it's a 3. So you show it 3, and you tell it it's 3. You show it a 2, you tell it it's a 2. You show it 5, you tell it it's a 5, and so on. You do this with millions of images in different ways of writing, as was here, different ways of writing the 0, different ways of writing the 1, different ways of writing the 2, and so on. When you show it to it, the success happens, and the training is mathematical, so there's a point we say that it's trained enough. The word enough is a key word here, but in any way, without getting into detail, there is something called overtraining and undertraining, and they both have disadvantages. So it's kind of an art also, like a sense of the problem. So it's very, very interesting. This is what we did in the 90s, and AT&T came up with this network to help the postal service. So quick revision as we'll get into the training again. So the neuron transfers information or transfers a signal from, if the inputs add up enough to the output, and then they get connected. And this is basically an imitation, mathematical imitation of a single neuron. Connecting them together becomes this, what we use in software, that is called neural network, or network of computing elements simulating the neuron. And this is called the input layer, and this is called the output layer. And in the middle, there is what we call hidden layers. There is huge advantage of having them, choosing how many and how big they are, like how many means cascaded together one after the other, and how many they might not have to be 3. These 3 can go to 9, for example, then they can go to 8. That is where the whole work of the 90s and the 2000s, how to figure out the best optimal number of neurons. So we'll not get into this. So if I put the number 2 at the input, what do I get? So the number 2 here, imagine this picture, I take the first row, and then this is the first row, and then I cascade with it after the second row. So This picture that is 28 by 28, if you extend it out, it will become 28 times 28 pixels, which is 784 pixels. This is the input. I'm showing the network a 2, and I'm telling it it's a 2. It has to figure out on all of the middle here, all of the mathematics, that when I show it another 2 in a different way, it should tell me out it's a 2. That is basically when the model is trained. When the network is trained, and I have a model that maps specifically, it will not map cats or dogs, it will just map specifically handwritten digits. I should get a 2. If I do not get a 2, I give 3 and 6, then it can give both, two things. Then we need to train. Train means show it more 2, show it more 1, show it more 3, and so on, till you get the result that when you show it a 2, it will tell you it's a 2. And when you show it a 3 consistently, you have to test all of them. So this is how a 3 looks to the computer. It's a 28 by 28 picture with all of zeros, and these are ones, which is when you write it by hand, this is the whole shape the 3 looks like. So this image is extended and fed into the network. Here is an example. So the 9 is the same thing, and you feed the 9 here, and you should show it a 9 outside. This is the picture of the input. This is the training. We're not going to get into the training. The training is finding a minimal of a cost function. Here is an animation of what's happening. So after it's trained, this 7, when I extend it and feed it into the input, it gives me out a 7. That means it is trained. If it gives me anything else, then it's not trained. This part is called the model. This mathematics connections between the input and the output, this is called the model. Now we call this the network is trained, and these connections are called the model. So the model with text, with large text, is called large language models. But that's where the word model comes from, is that you're able to map correctly by training the input, and it recognizes it because you have trained it to recognize it. That's a mistake. That's during the training, is that you show it a 4 and it gives you a 6. That's not trained yet. You show it a 2 and it gives you an 8. By the way, gives you an 8 means that this digit or this value of the y here is 0.9, and the rest of them are 0.1, 0.2, 0.3, 0.15, much less than the threshold, which usually taken as 0.2, and anything above 0.9 is a 1. So these are not hard-coded like white and black. This is the fact that giving you the right answer means that this one gives output as 0.9, while the rest of them are very, very low. So the output 0.9 is the answer. So that's at the 8. And I need to give the principles here. It will be a little bit overwhelming, but basically all of this classification, this is called classification. I'm classifying digits between 0 and 9. Classifying means when I show it to it, it tells me this is a 0. When I show it a 9, it tells me it's a 9, anything in between. That is called classification. The whole big picture of classification is you have a bunch of data and you find the optimal line that can separate them or can connect them together as a relationship. So that is the whole idea, is called least square method. That's neural networks is a very amplified, bombastic least square method fit. But instead of using a line, it uses a very complicated surface that it figures out on its own. So you have a bunch of data, you go to the lab, physics lab, you do some experimentation, and you say, I need the best, you define, I need the best y equal mx plus c or y equal a plus bx that fits this data. You do it mathematically or you do it on the calculator, it uses something called least square error method. What the neural network does, it finds this line for you, but for very complicated sets of data. That's the whole basic principle. If you want to understand the concept, how does it do it? It's a mathematical solution between points, the digits in the input, these are the x's, and the answer at the output, these are the correct answer, and it figures out the mapping line between them, although it's not a line anymore, so that when you show it any of the digits, it gives you the corresponding y. So it's a very, very elegant, complicated, high order high order function, least square fit. That's what a neural network does. The digitization, of course, this would not be done with analog signals. It has to be, things are numbers. So the emergence of the digital field gave first digital logic, and then combinational logic, and then memory logic, and then programmable logic, and then the software on the programmable logic, and then intelligence systems, and then learning systems. We are in the learning systems. So this very early on, creating thinking machines, obviously it was a top secret, it was in the Navy. And these are considered as the fathers of the AI. Somebody called McCarthy coined that term, but Marvin Minsky and Seymour Papert are the first people who thought of classifying machines that can classify data. In the 80s, this is there is one of the actually very, very strong reasons I wanted to pursue grad school in the States is NavLab. So in the 90s, actually in the 80s, this is what Tesla does today. So this technology, this whole truck has computers in it. It goes at about 2 kilometers per hour because you don't have the hardware processing speed, but the theory are being built then from scratch. Every line of code is being written from scratch. And inside the computers, they called it CMU, Carnegie Mellon, called it Alvin. And here is the Sun workstations. I don't think you will get a chance to see one of them, but this is what we worked on in the 90s. This is all inside the lab, the van. And that's a picture coming from the camera. You see, we need things to be digital, exactly as a handwritten. Imagine this is the 2 or this is the 9, and we need the computer to know where the road edges are. So we need to train it where the road edges are, but we need some pre-processing on the image. So this is all pre-processing that's done. And how is it trained? It's trained by a driver as the lab is moving in a lane. The driver is doing the turns, and the computer is recording the steering angle. So it gets this picture as an input. Here is a turn coming, and then when the driver reaches this turn and it turns left, then the computer registers that the angle of the steering is going to go with a certain angle. So it records that with this picture, the angle of the steering has to be this. That's the training. With this picture, I have to steer by this amount. With this picture, I have to steer by this. So a human driver, as in the case of the digits, what's showing it the numbers, what it should say. Now a human driver is showing the steering angle of the wheel on the fly, and the network is being changed. When I see this image, I steer left. When I see another image, I keep going straight, and so on. So this is the training of the NavLab on pictures coming from the camera. You can see it's very pixelated because that was the processing power could do. And with this, they can do 2 kilometers per hour as the driving speed. So here is the network here, and it got trained by a human driver driving, and the computer is seeing the pictures coming in, and that was the training. As exactly you were writing the digits, and then somebody tells us that this is a 2 or this is a 9. Now instead of it's a 2 or a 9, this is the steering angle that you need to do when you see a picture like this. So that is called the training. Here is slight left. That would be the output when you see this picture. So the network learns from a human driver what it should do on its own if it left to be driving. This is the foundation of really applying this into robotics or doing decisions using the neural networks. These are pictures from within the network itself. Is very interesting to process what happens inside the network, what happens inside the thinking itself. That's very, very useful for researchers. So here is examples of the steering, and these are all output by the network, saying I need this degree, which is between total left or straight or right. This is all gradual degrees between the total left, or 90 degrees left or 90 degrees right, and going straight. So one of them gets on, and that is the amount that the one of these output will become on. Like exactly when you show it 2, it gives you 2 at the output of the network of the postal code recognition. These are called neural networks. The foundation of AI, but AI gets amplified later. Mainly the focus was on computer vision and imaging. It wasn't much on text yet in the 90s and the early 2000 till 2010, 12. And then increasing layers in the middle between the input and the output, because the layers increased, they called it deep, and it became deep learning. So that's the word deep is the amount of hidden layers in the middle between the input, which was the digits in the case of recognition, the digits, or the image in case of the nav lab, and the digit recognized, the output layer, or the steering angle of the car in case of nav lab. What's in the middle here is hidden because the network, you build it in by mathematically, and then it figures out what it needs to. That became a very high focus. Still, somebody from Toronto in 2010 did a huge recognition degree with images that Fei-Fei Lin in Stanford put called ImageNet, and became the testing of any neural network, how it can do good in training and recognition. And that gained so much traction. Since then, it didn't die. It has been very pockets of research here and there till 2012. These are now become what we call deep networks, and you could recognizes all types of things, and that's what really happens in the Tesla. All of this gets fed into recognizing the everything on the road, and you train it by millions and millions of images of everything on the road till it becomes safe enough to make decisions based on the recognition. It can highlight, if you train it on dogs, it can find them and label them and so on. Here is applications also in navigation, in sports. So 3 major take-home points which will relate to our philosophy, because I have a goal at the end when we see the philosophy of AI and understand how the mind works. Our mind does science and theology. It's the same engine. It's the same neurons that do science and theology. And I want to push the fact that our theology is logical. Our Orthodox theology is logical, which is the creation and the fall and the salvation, that it makes complete sense to the thinking mind. That is in part 2 or at the end of part 2. So here I'm laying the foundation that what the replica of the mind mathematically outside does, it learns a pattern, and that pattern, whether it's handwritten recognition or how the road looks like, it represents the data in a certain way that the computer understands. And actually our mind, there is pre-processing. I'll discuss it in maybe in part 2, when the eye looks at something, as an example of how the data is modified before it gets fed to the brain for recognition. And there is also data flowing from the data to the recognition, and from the recognition to the data. Yani meaning what? I feed it an image of the digit. That's called bottom-up flow of data. I feed it the image of the number 2, as we saw. The top-down, I tell it it's the number 2. In humans, you see, for example, a cat that's part of it is covered. But so your eye sees part of the cat, but the brain, because it knows it's a cat, it fills in the blank. The mind does so much filling in the blank of things that we see. That's called top down, is that the brain, because you already saw it before, fills in what the eye is not seeing. So the eye gives data, but the brain also gives recognition, and the combination together, that's called top-down recognition to the data, bottom-up data to the recognition. There is always combination. We cannot stop doing this with our mind. It does all the time. And that happens here also in learning networks. Okay. Any questions so far? Do we understand what a model is? Did you sleep? Keep going? Okay. If this part is tough, don't worry about it. We're going to get into the philosophical implication, which relates to the faith and to the basically us as humans, as Christians. So this is just for us to know, people who are interested, and like a crash course on what does it mean a model, what does it mean training, what does it mean recognition, and all of that. So this is it's more complicated than this, but this is the basic element of what it means that I get a software and I can show it images and it recognizes what it is. It happens by this method of training. And training is a mathematical work that basically figures out a function that maps the input to the output, but it's a very complicated function. So neural networks were invented to figure out the function on your own, rather than in the lab you figure out the formula or the function, whether it's x third degree, second degree, first degree, that fits the input to the output. It was invented to figure it out. There is disadvantages because when people use this, they become lazy. Like, I am just going to give it the data, give it the output, let it figure it out. So we lose the element of geometry, we lose the element of mathematics, we lose the element of mathematical thinking, mathematical fitting, matrix solutions. So when the problem is very, very complicated, which was AI is very suitable, but it gets used now in early coming of this tool, it relieves people from thinking how to solve it mathematically. It lets the network figure it out. This, I will not discuss it, but this is what generative AI embryo is. This is the first time where you can have a network train another network, and then it generates. So this is basically two competing networks. One learns what the dollar is and starts generating it, and the other one tries to generate the dollar from the knowledge of the first one, and then they compare it. They compare whether the generation was good enough. So this is called generative adversarial networks, that can a network working in parallel with another network generate a dollar, and generated to the point that when you compare them, you cannot tell the difference. And this is where comes the word that now the network not just learns, it can generate data. And that's what we're living with today. We didn't just learn text, but we can generate text. So it started with the GANs, or the generative adversarial networks. So GANs are composed of two networks. The first one is a backpropagation network. That's the most common way of training. It's called backprop. It's used all the time because it's the most efficient way of training a network. The second one is a generator network. It generates data. That is what we're living with in the chat GPT. The G is for generating, generative. The top one is trained in the traditional way, and then the second one tries to imitate the output to get the result, and they keep comparing, and till the one that generates the dollar with correctly. So this is a bit of detail in the GANs. I will skip it now. This is what deals with text. There's some added things, and this GPT generative predictive transformers are a new type of data. Completely, I didn't explain it because it would be very, very, very confusing. So at least we know the concept of model, the concept of training, the concept of how mathematical elements learn data, learn patterns of data, like the digits, like the shape of the road, and so on. Using it in now the second part of this is using this in ministry. Of course, there's so many. I use ChatGPT all the time. In Zoom meeting, I can transcribe this meeting and summarize it. Maybe I should have done this. So it's continuously eating data, and it can do whatever with it, whether it summarizes it, whether it rewrites it. All of this comes from millions and millions and millions of pages that created. It doesn't understand anything of what's doing, by the way. It just looks at sequences of words, and the sequences of words statistically will happen in that order. So it generates it in that order, and we feel, oh, wow, it's thinking. That's basically what it is. It's statistical generation of the most probabilistic words that come in order. How many words? That's called datagrams, that or skipgrams. How many which decides on the complication of the network, how many can predict forward and how many it has learned from backward. The bigger it is, the more computation you need. So all what it does is statistical order of words, and we think it's thinking. But these statistical order of words are learned or are in it or are generated because it has seen millions of texts before that has the same order. So when something comes close to it, it generates output for you as your type, for example, in your Gmail, and you say something, then comes up with the next 3 words, because it has been trained that when you see this backward 5 words, the next 3 must be these 3, or it proposes to you as they say. When you say yes, that evens add to the weights that this is correct. When you say no, it gets fed back as an error and retrains. So that's what happens with text in a very, very high level explanation. Document segmentation, you can do this on if you have any pamphlet, you can do on document or I with Google. It can get separated for you. You can feed it things that are already the bank statements that are already trained for. It can segment it for you, and it can take your data automatically and store it for your records, basically. So this is a form of document AI, which is document segmentation, which you've seen with your iPhone and so on. So that's a very useful tool that I showed it this, and it cut it into these fields and cut the text and put it for me here. So you just feed it, try document AI, it will do this for whatever documents you have. Handwritten forms, also this is handwritten, and it cut it into parts in order if you want to store receipts and so on. So as we said, in text recognition is different than image recognition. Image recognition is called convolution neural networks. The word convolution has something to do with a mathematical thing we do when we have a kernel and it has to find something in the image called convolution. What we have in text is called large language models. But the idea, it recognizes a sequence of words. The words in AI lingo, it's called tokens. So that sequence, how it generates, as I said, is based on it has seen millions of documents that if I see that much of words backwards where I'm standing, behind me comes that, before me comes that many words, I can predict what are the next 3. That comes from just chewing a handwritten, documents one after the other. And the text in there is called a token, because tokens can cover more than just text. This is why it becomes language agnostic. So you can do it with Arabic, you can do it with Chinese, because it doesn't understand the language. It just understands the sequence or the statistical sequence. The relevance is a lot of research about the relevance and the reasoning. Can I keep the topic? Can I figure out the topic and keep it in the same topic so that when the user asks me to generate something extra about this topic, part of the training is to keep track of the topic, then I can stay within the context. That's where, again, the money is how to make it able to stay relevant to the topic. And then reasoning about the data, that is where we'll never stop, that we can make the machine actually become logical. And lots of architectures are being invented and lots of hardware. And that's why there's so much money poured into, because you have to have very, very strong processing architectures that are chewing on this data all the time. So today's form of AI is, here is the basic component of what we do every day. There's large language model, ChatGPT, generative predictive transformers, and you ask it a question that's called a query. And then it has sources. These sources could be billions, and it has been eating, and it keeps eating up sources from every email you write, every platform that the people have host email on, or whatever, YouTube videos, whatever it may be. It will. That's why there is the public. The network drives. The network drives is not just to do you a favor. The network drive that Google has, Apple has, everybody has, is for people to store their documents on it, so that these machines eat on it. And it becomes we are supplying the training data every single second to these large language models. And these are the sources here that they take from the network drives that we store our data on it. Of course, if it's in your hard drive, there's no access to it. But for practicality, if we change computers, if we want to access from it, all of these advertisement is basically to lure you to use their email and to use their network drives so they can have access to as much data. And the company that has more access to data, the company will succeed. So these are the sources. So there is a query and there is the answer, and comes from the large language model. Query is a field actually called, there is a field called query engineering, which is how to ask the question. That is one of the basic things that you can learn in order to get relevant data, not wrong ones. That is called the query. Because if you ask something general, what will come out will not be very relevant. But if you tune it to specifically ask, the information will become more and more useful, more and more tuned. Now it's capable of keeping context. It's capable of keeping the history of the information and the topic as well. And there are some now additions where you can click on reasoning. I'm sure that's more advancement that it can pull in from. I don't know how it will work inside, so I cannot claim how it's doing the reasoning. But obviously, people are abreast of what is needed by the user is to give relevant information, not what we call hallucination. The problem with LLMs, it doesn't stop talking. It will keep giving stuff. So that's called sometimes hallucination. And one of the things to solve it is that you as a user have to weed it out. And that's why live usage of this in ministry might be not at the prime point yet, but it can be used if you're going to revise the result that will come out, because there is a lot of theological information there. There is, of course, directions to have only orthodox information to train it on, but you have to start from a blank model. Training a blank model is not easy. You have to really provide like thousands of data. And in my opinion, pre-processing this data is going to be actually giving a lot of results. I got much better results if I write it in a way that I know how the LLMs will chew up on it. It's a black box, as we said, and it's as is limited change to the inside unless you start from scratch one and train it yourself. And that's why where you get a better bet is to ask the question relevantly and revise the results that will come out. It offers, I mean, you use it all the time, so you can tell me more about what you use it for. People who do systems engineering, that side point, see that it cannot solve system solution. Like you can tell it, give me software that does this. But if you give it all of the components of whatever, an automated dog, for example, and tell it, find me the bug because why this leg is not working when I run the code, because this is system, it cannot figure that out. So system solutions are still very much it has to be done by the human because they know every input output of the system. Maybe later on within the company, when it feeds all of the information of the bugs that happened, it will become like the repository for the solutions. So that's another model that we can do. If you augment it with Christian solutions to already existing LLMs, maybe it will, but how much we can tune the answer. But with all of the people writing Christian sources and storing it in drives, it gets better to give answers, but it's also very dangerous. Like you cannot leave it to people and say, hey, go and prepare a lesson using this. If it's possible, it can be done, but it has to be revised because the answer can be hallucination and can be dogmatically wrong because the sources that are there are non-orthodox sources as well. So if you choose the route of starting with a completely blank model and feed all of the orthodox sources in it, you have a better chance. But I'm not sure if it will be trained good enough. And if you use the route of using an already existing model like ChatGPT, then you can do this, and you can, as I said here, do the query over and over to fine tune it, and don't do it live. Because the answers might be just flat out heretical or lacking. And if people take this as dogma or use it for just preparing lessons, there's a big danger there. So you can use that to reframe it, to give ideas, but that's not going to be the lesson taught in the church, because it has to go through scrutiny of really understanding what was the answer. The advantage that there's a lot of law sources to give you from, but the disadvantage, you really have to filter, and these sources could be heretical, so you have to filter what it gave. So that's an idea of using it for doctrines. You can feed it with these data. That's called brute force approach. I'm trying to do something different where these are modified, because knowing how it works, modified in documents that's self-written before it fed in and get the data out or correct data out. But it's still a while to go. So these are the main fields of our work. The fathers, the scripture, fathers, I'm calling this theology, the councils, which is historical. So there's historical events, and within the historical events, there are dogmatic events. Maybe I should add it here, dogmatic or doctrines, and liturgical. So all of these are the sources that we want to amalgamate together to get, and integrating it together cannot be just automated by asking ChatGPT. I think there is an offline work to be done in order to integrate these together, and then gets fed into it. And I think it should get fed into a closed network that is not exposed to other data that's coming from outside. So this is a research direction. I have done this, in fact, the conceptualization. If I want to teach somebody the difference between Nestorius and Sensorial, can I manipulate the data inside the LLM? And so any sentence is represented inside the LLM mathematically in the form of a vector. So I thought, hypothetically, can I manipulate the vectors representing the statements of Sensorial to be in the same plane geometrically, and manipulate the vectors of Nestorius to be perpendicular to that plane, so that when I show it to user to train them on theology, I can separate easily in front of him the Nestorian statements from the Cyril statements. And successfully this happened, and it was very, very exciting that you can, like, knowing how it represents its site as vectors, I can manipulate these vectors to visually. And this is the part I very excited about, is how to use this tool to teach theology, not to just give it information and it spits it out. But that requires the knowledge of the working of the internals of it, so I can manipulate it mathematically, and that's very, very, very exciting. So there is certain concepts about Christian theology, faith and works of the law, this is a concept of a New Testament difference between the Old Testament. So we have to form our theology conceptually in order to train it well, not just a bunch of sentences. So this is what I call the pre-processing of the data before training it. And that's current work. So what we advise today is non-live AI. You as a servant can use it into getting data if you want to ask about church history or statements. But you have to generate a story from the sources. You have to iterate through the story to make sure that there are no mistakes. Divide your data into small chunks to achieve that. And then I had a podcast with the Gemini Google. I fed it a book did on the Eucharist, related to the creation, the fall, and the salvation that has to end into uniting with God. And it generated data that was not in the book at all. And that data is, let me see, I can open it here, and maybe you can. Bear with me. This will conclude, by the way, part one, before we get into the philosophical summit. Not now for sure. So that is the book as a source. I fed it in. I've been working on that book for a while, and I wanted to create it as a podcast, which is people actually, the podcast is completely generated by AI based on that source, my source, and see how it does. And at some point, it did a mistake. Let me see if I can run it. It did a mistake, and it generated something I never said in the book. So that's where, as an example, you can contain the input, but you might not be able to control the output. So here is a generated podcast from the book, based on the book, and I can add my own sources here, and we'll just get the beginning of it to just get a feel of it, and then I'll show you where the error is. I hope I remember the minute correctly.
All right, so get ready because today we're diving deep into something ancient, but still super relevant today. The Eucharist.
Right.
Now, the source material you guys shared for this deep dive, it takes a really unique approach.
Yeah, it does.
Like it frames the Eucharist as the solution to a problem.
Yeah.
Almost like a theological mystery novel.
It is interesting how it starts with, the scene of creation,
Yeah.
and all of that. And then it's like the fall of man is the problem. And then ultimately that leads us to the Eucharist being the answer.
Like the solution.
Yeah, it's a pretty compelling way to structure the argument.
It is. And what I thought was so interesting, like especially intriguing, was how this source describes the Garden of Eden.
Oh, yeah.
Not just as, a beautiful garden,
right,
but as like a consecrated space, almost like the original church.
Uh-huh.
It talks about the ground being sanctified by water and the Holy Spirit's presence.
Right.
So that connection
in this
on that.
Sure. Question. And exactly. The establishment of a
for instance, one objection I've heard is that it's cannibalistic.
Okay, so I advanced here to the part that is never mentioned in the book, but the generative AI, because this is not a closed model, because closed model, you have to train it with tons of data. So let's hear together, and that's why I say this cannot be released, although everything else was actually quite well. But here is the part that it generated.
Way of understanding the entire biblical story.
It is, isn't it? And it invites us to think about our own participation in the Eucharist in a much deeper way.
Speaking of which, I know some people struggle with the concept of the Eucharist.
Uh-huh.
They find it confusing, even off-putting.
Yeah.
For instance, one objection I've heard is that it's cannibalistic.
Right.
The idea of consuming flesh and blood, it just seems primitive or even repulsive to some.
That's a very understandable reaction. It's a concept that requires us to move beyond a purely literal understanding.
Right.
The source addresses this directly.
Okay.
Emphasizing that the Eucharist isn't about physical consumption.
Yeah.
That is where the mistake is. Of course, I would never mention the book that the Eucharist is not a physical consumption. It is a physical consumption. That's the whole essence. We consume physically the body and the blood of the Lord. The sense of it feels like bread and wine, but it is in reality completely the physical consumption of the body and the blood of the Lord. So that got generated, that would never be in the book. So this is an example of how to be very careful, very, very careful of what it can, although it's so attractive, this is an amazing tool that it took the book and made it into a conversation. But if I hadn't, if I have to revise that conversation, and there is no way I would release this, because that statement is torpedoes the whole essence of what communion is. So I hope so far there is some understanding of what AI is, what model is, what training is, the generative concept, which works with you can generate sentences, and you can see now that you can generate images, because it has seen tons of images. It can, we don't need to get into how it does it. I am also not 100% familiar, but it's the training of the data from the video and labeling the video and segmenting it. When you ask it to generate an image, definitely it can contextually put things together, but it's very remarkable. So so the model of using it in the church is basically with great carefulness, and it has to be supervised, and the servants have to consult before giving the lesson, not to take this as the data, but it can be useful data till we get to the ability, which is maybe multiple groups are working on, of generating guaranteed data. There could be a verification layer. I'm getting the direction of pre-processing the data in a way that, because I would know how the training happens to an extent inside, manipulating it mathematically for a specific task of teaching students how to separate Nestorius from, how to see visually. For example, on the concept of Theotokos, if there is, it's on another computer, unfortunately, that if I want to relate the Theotokos, what did he say about this? What did he say about this? And they are visually in space, 2 points separated from one another, so they can conceptually see the difference between the statements. If you hover with the mouse on it, it will tell you what statement this is. So these are tools I think are going to be pivotal than just like let it generate papers or whatever. My passion is to make it useful as a tool for education. So I'll stop here before we get into the philosophical. We can do, I think if we get into the philosophical now, you'll be exhausted that I will not be able to grab your attention enough for the importance of the philosophical part, because that's really what's relevant to us today, the effect of AI on the human perception. How do we perceive humans? Are we a creation? Are we superior? Or we just created a better version of ourselves, which is AI? So I think it's important for us, without understanding this part of using it as a tool, we have to delve into the part of the philosophical implication of it. And I'll stop here. Any questions? I can't hear you, so.
AI, the Antichrist.
Sorry, I didn't hear what was said, but I'm glad it was funny. Was it Abuna saying something?
Yes. Is AI the Antichrist?
I'm open to this. It has angles of it as the Antichrist, definitely, and we'll do this more. Like your presence, Abby, both my fathers will be so important that we discuss the next things and how they promote this, that you can create a brain, you can create a mind, and how people get fooled actually that it's possible. So I'll have to differentiate between what the terms that they use and how they are used wrongly, specifically with a very strong push that they can create a mind. That was the main drive. So I think we will need a fresh meeting for this. This was just an overview that if you want to use it, please, with the supervision of the servant, you can do more queries until we're able to have a guaranteed output, either with using it in showing, like manipulating it to show correct theological data, or having a very close system where people upload all of the resources to it, which is, I think it's possible. It's just a brute force approach to it, but I think at least that the output will be safer than using the general ChatGPT, but we'll lose a lot of capabilities that ChatGPT is doing. So for sure, servants prep, servants meeting, servants, if they use it, please be honest that you revise the date. You have to revise it, because definitely it gets from ideas or areas that you don't know what's written in it. It can be wrong. For the most part, with Nestorius and Cyril, it was actually quite good, but I trained it on my own. Sorry, I fed it my own sentences in a way, and I wanted to see how it was represented inside. But also asking it generally of what it gives by itself, for the most part, it was good. But that doesn't guarantee, of course, that it's reliable.
Thank you. Thank you.
You're very welcome. Would you like to have part 2 next week? The philosophical implication? Because it's big. It's probably as long as this part, or with discussion it can get longer. So it's going to be very not useful to just jump on it now.
The follow-up be next week? The follow-up. No, next week there is, 27th.
Or another week. It doesn't have to be the next one. We can arrange.
I'll get Marion to adjust the schedule.